All right.
All right.
Excellent. Recording just started.
Okay, so maybe we should first introduce ourselves.
Yeah, sure.
Go
So, everybody, my name is Ryan Lambert. You've probably seen me around either on the Planetary Defense channel, or if you are in the Satellites channel, you've seen me there as well. I'm the Planetary Defense lead, so I pick campaign targets. I make sure that the pipeline hasn't fallen over, the bot hasn't fallen over for Planetary Defense. And we get published results for updating asteroid orbits as they do flybys, and we get better precision on where they are in the sky. And in some cases, we get light curves as they're rotating to eventually shape those asteroids. For satellites, I've been slowly putting together the satellites campaign. I know that some people don't find satellites all that interesting scientifically, and hopefully we'll be able to change that. But before I go into that spiel, let me let Franck introduce himself.
Hi, Franck Marchis. You probably know my name too. I'm the lead of the occultation program, but I'm also the chief scientific officer of Unistellar, and one of the co-founder, and an astronomer at the SETI Institute. So I'm leading this team. And today I'm here because I want to make sure that we explain why satellites are important and what we can do with them.
Yeah.
And Ariel?
Hello. I am Unistellar's comet lead. So I do similar stuff as Ryan, but for comets. And if you participated in the program, you know, we monitor them over time to see how their brightness changes. And we look for outbursts in particular. That's the most exciting thing about comets. But yeah, today I'm here to observe satellites. I'm the volunteer. So I'll be using the telescope today and sharing my screen.
Okay, so why don't we just start telling why we want to observe satellites?
Sure. So when you think of astronomy, you think of these really far away objects, usually even far away in the sense of the moon is far away. These objects out in space that are interesting and unlike Earth. So you might not think about satellites as doing astronomy, but they do have a very big impact on the field. If you think about some of the biggest telescopes in the world, they're situated on mountaintops, very dark sites, trying to find extremely faint objects at the very edges of the universe. 30-minute exposures. The last thing you really want is this big streak of light coming through your image that was there for less than half a second, but now has completely obliterated your ability to pull science out of the image you have spent the last 20, 30 minutes trying to take. So the fact that we have so many satellites now going up into orbit, currently it's around 6,000. There is a projected estimate of like 100,000 by the end of the decade. There's at least a hope. They're hoping for getting 100,000 up in space. That's SpaceX, OneWeb, Amazon's Kuiper. All of these different companies are seeing space as this frontier that they can now start launching satellites into low Earth orbit and competing for. And that has an effect on us because we like the night sky. We want to be able to see what all is out in space without having a satellite come crashing through. So part of this is we want to keep up-to-date coordinates on where satellites are in the sky so that we can start building tools to monitor where they are and alert people when those satellites are going to be in their field. How long will you have this field of view before a satellite comes through? What time is the satellite going to come through so that if you need to, you can shut the shutter on your telescope and then open it back up once it's gone? These are all things that astronomers as a whole are working on, and we think we can contribute to that, certainly with citizen scientists. The fact that you all are spread all around the world and that these are relatively short observations, that it's a short amount of time for you to have to dedicate to it. We think we could really do a lot to contribute to this. Yes.
Yeah, one more thing. Satellites are not only about astronomy.
Yeah.
We're launching a lot of satellites at the moment. Those constellations are more or less in the same area of the sky. I mean, the Starlink at the same altitude, OneWeb will be at the same altitude. There is a finite amount of space around Earth. And one of the fear we have, and when I say we, it's like everybody on this planet should be afraid of that, is that we have this kind of catastrophic collision between satellites. So one satellite encounter another one, they both destroy, and there is fragments, and these fragments destroy more satellites, etc., etc. So that's what we call the Kessler syndrome, and that will basically close us up out of this orbit, and we want to avoid this. So one way we can avoid that is by monitoring satellites continuously, knowing where they are, and being able to alert two companies, for instance, if two satellites are very close to the impact trajectory. This almost happened multiple times. We heard about it in the past. It may happen. So one of the contributions of people who observe satellites is also to save the close environment of Earth. So we have satellites for the rest of our life and beyond.
Yeah, Kessler syndrome is a very real concern, especially it was like first theorized about, I think, in the 70s or 80s. And the fact that we have continually populated this low Earth orbit, it's becoming a bigger and bigger risk by the day. So yeah, this is a way to really help not only astronomy, but to make sure that space stays open to all of us, that we don't lose our ability to launch ourselves to the moon or Mars, or launch satellites that are telescopes up into orbit in the future. So yeah, I think hopefully you recognize this is for a good cause. I think it's actually a very interesting area of study. So I think what we'll do now, and if you have any questions, feel free to chime in or to raise a hand, and we can stop. I don't think that's big a deal. We have this for about 45 more minutes before it's going to close us off. But I think if there are no questions, then we will turn it over to Ariel for the moment. We're going to walk you through basically what you want to do when you are trying to observe satellites. So we have a tutorial that's written up. I wrote it. I understand I'm not the greatest writer, so I think this is probably a more fun and entertaining way to learn how to observe satellites if you haven't ever done it before. So we have Ariel out in the park right now. She is currently on a Wi-Fi hotspot, and she's going to see both her computer screen and her phone screen, so we can see what's happening on both screens.
Okay, yeah, I'm going to share now.
Okay, and it might not.
Sharing.
Okay, great. It does let you.
Yeah, it does let me. So can you see I have Slack open and I have my phone screen open?
Yes. So yes, the Slack is on the left and your phone screen is on the right.
Yeah.
Cool. So yes. So we're doing this basically as you've just joined Slack. You have all the channels that you've been added to. What do you do now? So the first thing you want to do for the satellite tutorial is go to the satellite channel, and then up in the top left corner is the pinned messages. So there is all of the messages we have pinned for how to actually do satellites. The very top one that's the one you're always going to need. The other ones are helpful. They have a lot of the same information. That tutorial page is the one that you can just click on, and everything you'll need is there. So yeah, Ariel, if you could open that up. And that is this long tutorial page. The first thing you're going to do, basically, once you have your telescope out and you have it oriented and you're set up like you would do a normal observing session, is you're going to see what targets are available for you. So we have a couple of different scripts here that go through the different types of satellites. So we have Starlink's Generation 1, which are the older versions. There are like 6,000 of them up right now. Starlink Generation 2, which is when SpaceX took some feedback and has started to try some mitigation techniques to lower the brightness of their satellites. So that's another set of Starlinks we're really interested in monitoring to see how effective their mitigation techniques are. OneWeb and Kuiper. Kuiper is actually Amazon's new satellite program. There's only 2 of them up in orbit right now. So unless you're in a very specific spot, you're probably not going to be able to see those. But each of these links will take you to a web page where you can generate an ephemeris to see what types of satellites or where these satellites are in your sky field, and you'll be able to pick them as you want. So yeah, Ariel has clicked on the OneWeb prediction page. So basically, what this is we have created some Python scripts, some code that you can run, and it will generate. It will find out what satellites are. And it looks like this. It's basically a code we all share that you can run in your browser. So the only things that you need to know about this, you shouldn't ever have to actually edit the code, is you can put in your latitude, longitude, the time that you're starting, the date, and the start hour and end hour of when you want to observe. So it's just giving the code this information about where you are and what time you want to observe over here on the right-hand side. So Ariel has nicely filled this out already. Her latitude is 38 north. Her longitude is 77 west. So the way that the latitude and longitude are formatted is it's going to be a number, and then either N for north or S for south. And then the longitude is a number, and then E for east or W for west.
So one question, how do you find your latitude and longitude in this format easily?
So the way that I do this is I put my address into Google Maps, or wherever I'm observing from, into Google Maps. And then if you click on the map with Google Maps, it'll up in the URL, there will be a little spot where it is the latitude and longitude. That's the way I do it. There are tons of things online as well. If you don't like Google Maps, you can just Google, how do I get my latitude and longitude? But that's, I think, the easiest way is to just grab it from the Google Maps website.
Yeah, that's what I did. I just dropped a pin at the park I was going to, and it gave me the Latin law, and it was very easy.
Yep. Then the
UT time, I mean, the time is what? The time where you're located?
Yeah, it is the UTC, so that is the universal time. That is basically, you'll have to do a little bit of finagling. I use Ariel. I am also going to share my screen for just a second.
Oh, sure.
So I use. Oh, why won't it let me just show everything? Here we go. Let's do the.
It should.
Yeah, we're just going to show. So I use this date and time buddy. This is.
Oh yeah.
This is pro tech, but I love it because I could just put in a bunch of different places, and it will show me what the time is now. So I'm in San Francisco right now. Let's actually refresh it and make sure. Yeah. So right now it's 1500 hours in San Francisco. I care about UTC. I scroll up. Oh, it's 23 hours in UTC. And if I look over here, the date is January 17th. So
one way I do it, which is easier, I believe, is that I Google UTC now. Google UTC now.
All right, we can do that.
It may work. Click on that.
Okay.
And here you have your UTC time, right?
Yes.
It's much easier. I mean, if you like complication like Ryan and diagrams everywhere, use what he says.
Sorry, Ariel, you'll have to share again.
Well,
Go ahead.
yeah, I will. But I'm just going to put a vote for the thing that Ryan showed, because I was planning my observation earlier today and I didn't want to do the math. And so I used that tool.
Sure. The key, though, is you will have to do a conversion. I will in the future when we are putting all of these scripts together into a more final form. We will have it where it will take your latitude and longitude and figure out what time zone you're in, and you can just put in your current time. Yeah, Bruno's right. The easiest way is to live in the United Kingdom. Then you don't have to do any conversions at all. But so once you have picked out your date and you have decided either ahead of time or like right now what the hour beginning and end that you're going to do is, you put those into this these boxes on the right-hand side. And it's okay if you'll notice that the start hour is 23 and the end hour is UTC is 1. So the script is smart enough to recognize that you have rolled over to another day. It will figure all of that out itself. You don't have to worry about it. Once you have all of that plugged in and you are confident that you got the place right, you got the location and the time right, you click that little play button that's over on the left.
It's super tiny. So if you don't have good eyes, you will spend a lot of your time trying to find.
Complain to Google Colaboratory, not me. I did not make that.
I asked for the button to be bigger. I'm sorry.
So this warning is going to tell you that, hey, you didn't make this and Google didn't make this. So if it's dangerous, we can't stop you. I promise it's not dangerous. If something happens and your computer blows up, 100% blame Franck.
Yeah, I'm running anyway. I trust Ryan from Unistellar.
Anyway, now what it's doing is it's taking your location and it's downloading where the satellites are predicted to be in the sky. These get updated every few hours where they are. And it's running those orbits basically through the time that you care about, the time that you gave it. And then it's checking to see, is where it is during this time above you? Is it above the horizon? can you see it? And is it behind the shadow of the Earth or something? Or is it out in the sun where you're actually going to see it? It's going to be bright enough to see it. So you can see down here at the bottom, it's doing all these like installation stuff. You don't have to worry about that. It'll run, and then you see this one took 13 seconds. At the very bottom, it says completed. And so now you do. It has created a little text file for you. And if you go to this folder icon on the left,
and there's a tiny icon.
Another tiny icon. The file that we care about is called ephemerisresult.txt. That's everything else is completely not useful to you anymore. So you can download it there. And then Ariel has actually previously downloaded this onto her phone.
Yeah.
And so we're going to pull this up and be able to look there. Hi, Karen.
Okay. Yeah. So this is that file just opened on my phone.
Yes. And so it's a little bit small here because the phone is small. But in general, the file will always contain the name of the satellite, the time that it is going to cross your field of view, the RA in the deck, and then if you want to try and figure out how high above the horizon or what general direction, we have the altitude and azimuth as well. Oh yeah, okay. Mike says that if you have an iPhone, you can just you can click clock and select the world clock as well, rather than to do the UTC, rather than having to do a big conversion or go somewhere. So yeah. This ephemeris text file then has some deep links. It's got 2 deep links. So if your phone likes deep links and it accepts deep links, you can highlight those and it'll take you to the app and you won't have to do anything special. So
why 2 deep links?
So the first deep link is so that you can actually catch the satellite itself. This is going to be a very short exposure time, 150 milliseconds. Frame exposure time, so that we can really see that satellite traveling through the frame, because the satellites are not going to be in frame for more than half a second. They're there and gone very quick. But then in order to get photometry of these satellites, in order to get an estimate of the brightness, we need some stars to compare them to. And it's very hard to find stars that show up in 150 millisecond exposures. So that second deep link is for before you move the telescope. It's going to take a longer exposure image of that portion of the sky that you were just looking at where the satellite came through. And so that's going to end up helping us to get photometry down the line as well. I actually was just doing that a little bit before this. I did manage to get satellite brightness of about 6 magnitude. So these are very bright, definitely bright enough to be seen by eye a lot of the time. So you have this list now. You have all of your satellites in this list. What do you do next? The way that I go about it is that I look at what time it is, and I usually try and find a satellite that's passing by within like 5 minutes. It's best to give yourself a little bit too much time to get to that portion of the sky and get everything set up than it is to get too little. So currently it's 3:20 in UTC. That would be 23:20. So we're going to look for 2323 is what OneWeb 0434. Let's see, OneWeb 0008 crosses the field at 232446. So let's go down one more. OneWeb 0063. All right, and this one should cross Ariel's field of view on 25 minutes after the hour. So she's selecting this first deep link. And then she is going to open that deep link because it works on her iPhone, and it'll take her straight to the app. She shouldn't have any problems. So she's pointed her telescope before. It knows where it is in the sky. She can now, just like you would for exoplanet or planetary defense or occultation, you have your deep link, you go, and the telescope is going to do everything itself. So
we know the direction and elevation with this file?
Yes, so the altitude and the azimuth are 2 columns at the very end there that are included for every pass of the satellite. Cool. You will know how far above the horizon you can expect it to be. Usually it's no more than 45 degrees above the horizon. I have very rarely had satellites that were straight up ahead, but sometimes they do go up there. But a lot of the time, because we're trying to catch these satellites when they're in the sun, from our point of view, They're going to be low on the horizon just after sunset or just before sunrise.
So that's something important. Remember that satellites don't shine light by themselves; they reflect lights. So they reflect the light of the sun, to be more accurate. So that means that you can see them at a specific time. So typically for Starlink, you see them 1 hour, 1.5 hours after sunset.
Yes, my rule of thumb is 2 hours is about the limit for Starlinks. 1.5 is when you're at the best. Like after 1.5 hours, you start to get some duds.
And for the OneWeb, we know
OneWeb, it's usually a bit. It's like 3 hours. It's a little bit more, but not by much.
Yes, because they're higher in elevation. So that's right. Okay, so we're ready?
Yeah, it looks like it. So usually, like I said, these are very quick observations. When you get really good at satellites and you're ready to go, I think it was Neil Yablonsky, somebody. Franck muted himself.
Okay, I was like, I lost you guys.
Yeah, you muted yourself.
I didn't touch it.
I don't know how you did it. Anyway, so yeah, as we were saying, these are very quick observations. We had somebody, I think it was Neil Yablonsky, mentioned once that it felt like being a gunslinger in the Wild West. You're really, when you get the motion down for all of this, you're like, okay, slew, take a minute-long exposure. All right, done with that. Slew, take another minute-long exposure. And it's just it's a game to see how fast you can do these things. Usually we have people observe and they get 5 or 6 satellites over the course of maybe 30 or 40 minutes. So very cool. Right now we're going to wait for, we just saw another small satellite. That's not the one we want. So this is a minute-long exposure. So I usually wait 30 seconds before the satellite is supposed to pass through the field, and then I'll hit record. Ariel, do you remember it was 25 after, but was it 30 seconds or so?
I will check really quick.
Okay.
So it was 25:07.
Okay, so let's see. Right now we are at 24 and 45 seconds. So you're good to start. And what we, So now you'll record, and what we should see is these are usually very quick, very bright. We should see it pass through within half a second of the predicted time. They're usually very accurate. So let's just keep an eye out for it. And if we don't see it, there it was. So it was going across in this direction, but we did see it. It's not the brightest one, unfortunately. I'd hope we'd get one that was really bright. But
I did see it though.
Yes, so that's a successful occultation, or not occultation, a successful satellite.
Thank you.
You'll notice that we're doing this asteroid occultation science campaign, which is why I said occultation. I get confused because I read the word. So we're going to let this finish up. Yeah, Mike blinked.
Yeah, I blinked too. I didn't see it. I just saw one image.
I spent too long peeled with my eyes at the screen because I'm paranoid I'm going to miss it. But okay, so that is now done. We're going to continue on, and then you may be tempted to move on to the next satellite. Do not do that.
This is important.
Yeah.
Just pay attention because it's going to help Brian.
Yeah, there is a second deep link underneath each satellite in that ephemeris. So like I was saying, the first observation is to actually get the satellite. The second one, you don't have to be quite so quick about to get there. But before you move the telescope or go anywhere else, we want a longer observation, a long exposure observation. So the satellite observation was 150 milliseconds per frame. This one's a full 4 seconds. And the point is that we want to get stars. Nothing else has changed on our observing parameters, but we want to be able to get some stars in the field so that we can compare those stars to the satellite brightness and get an estimate of how bright that satellite is.
So we're basically pointing in the same location, but we send we send the telescope again to the same location, because I generally skip. There is a way.
Yeah.
At the bottom of this window, there is a skip. So I generally skip that, and I go straight to the part where we acquire data.
Yes.
So
So-
it's where I save time.
The telescope is not moving, so if you want to skip, you can. If you want to be precise in how you do things like Ariel is, totally fine to also hit go to again. The telescope will not move. So this one is a minute-long exposure of just the sky. And there's nothing else fancy about it. If another satellite comes through, I guess that's kind of a bummer, but otherwise, it should just be a very straightforward observation. So we wait this one out as well. We can't do this right now because we are looking at the screen, but usually this is the point where I'll pull up the ephemeris text file again and start planning what else I want to look at next. So this is a good time if you, I don't know, want to take like a snack break. This is the time to do it while you're waiting on this 1 minute exposure to get.
Yeah.
Is that normal? We don't see anything on this field of view right now?
It's something I wouldn't worry about. For me, if I hop in and out of the app a lot like I do, the screen will go a little blank sometimes.
Yeah, I think
it's been fine in the past.
I've never had the data be really bad after something like this, even if the screen itself is wonky. So I'd be more inclined to that's just a random incident and that the data is fine. So then, yes, Ariel, now that you are done with that, you are good to hit continue. Technically, at this point, if you only wanted to look at one satellite, you'd be done. That's it. You're good. The last thing that you want to do is, and we'll go back to looking at some satellites in just a second, but let's say you're at the end of the night. Ariel, if you could go back to that tutorial page.
Sure.
So down at the very bottom of the tutorial, there is reporting your observation. So currently, I don't have a good way of knowing that you've observed satellites if you don't fill out this form. I don't want anybody's observations to get lost. So at the end of the night, before you are turning in, try and remember to fill out this form so that I know that you have made an observation. I can go get that data. Currently, a lot of what I'm doing is by hand at the moment. We're working on automation to get this into a fully automated pipeline like the other science campaigns have. But until then, we don't want to lose anybody's data. We want to make sure we know who all is observing so that we can get you some results. But yeah, so basically the form is just, it's a lot like the other submission forms, including your name. If you can remember what satellites you observed, that's great. I would love you to give me that information because it's very hard for me to usually track down otherwise. Serial number of your EV scope so that we know which EV scope to pull stuff from, when you observed, how long you observed, and then any kind of comments if there was something weird happened. So like Ariel's black screen, that would be something you could mention in case I look at the data and I'm like, this doesn't look right. I could look at that and we could start to figure out what might have gone wrong in that instance. But after that, you submit that, you upload your data like normal, and you're good. You have finished an observation. And even with me talking through all of this and Franck talking and Ariel talking, is very quick. It's very quick to actually do. So I really love actually doing these kinds of observations for that reason, is it doesn't feel like I'm committing to an entire evening. You can do things in between other observations. Yes.
So why don't we just let Ariel doing one by herself, and we don't interrupt.
Sure.
We have an idea of the amount of time it takes.
All right.
Okay. Go ahead, Ariel. We are going to.
Wow. Okay.
Yeah. There's no pressure now. Just make sure you do everything.
Here we go.
Watching.
Right now it's 23:31 UTC, so I'm gonna pick one for like 33. Well, I'll do this one, 33:47. I think I can get there in time.
I think so.
Go. See, it's deciding whether it wants to show me the stars or the question mark screen. There, I got stars on there now.
I did see some flying by, so.
Yeah.
The stars look like satellites when when it's moving.
So-
I know.
Interesting is that if you do the Starlinks, you will see that they're generally in the same area of the sky. Like you can see a same series of Starlink more or less in the same area. So you can save time by always choosing the one which are close to each other.
Yeah. Yeah. Part of
Yeah, that's a good point.
method of doing things, sending in basically entire constellations of satellites means that you can usually catch them around the same areas. So they are quicker to observe that way.
Yeah, my telescope turned completely 180 around for this one.
Rookie mistake. No, you're fine. I think you still have
So
time.
You
a
still have
little time,
Well, it's at 33.
33, 40 something. So as
Yeah.
soon as it turns 33, I hopefully can
Yeah, it's about to be
start.
3 right now.
what
In
is this time she has here then?
I don't know.
You have a weird time on your
I- That's right. I only goes to 9:41 when I'm plugged into my laptop. But don't worry, I see the real time.
I
Okay, I'm gonna go ahead and
can't. You're
Go
good to
ahead.
start.
Go ahead.
You're actually exactly at the 30-second mark. So
let's go.
Don't blink, Mike.
All right, so we should see in about 15 seconds. This is the part that always makes me anxious, where I'm like, did I
I
miss?
know.
And I don't want to look at it.
Oh,
Woo, that was a bright one. Excellent.
yeah. Wow.
That's the part where I always get anxious because I'm like, did I miss it? Is it there? Did I miss it? And I don't want to like look at the clock to figure out if it's passed already because I'm afraid I'm going to look and then the satellite's going to be like, oh, cool, he's gone.
Yeah.
He's gone by.
Okay, so one thing I want to say is that if you don't see a satellite, it's an interesting information.
Yeah.
So you should write this down somewhere and send it to the notes.
Yes.
Because satellites move, they move them, especially the Starlink, they still, when they launch them, they move them in different orbits, they reorganize them and so on. And remember what we say, what we want is to be able to find, to get the orbit continuously, refine the orbit. So we need to know the one which are not where they expect to be.
Yep.
So this way we can focus on them in the future and try to find them.
Yep. And that is a very good point because it's one of two things. Either they're not as bright as we expected, which is interesting because that would mean that there was something to do with the orientation or some kind of mitigation strategy has been done on that specific satellite. And we want to know if that's the case, if it worked. Or like Franck said, it's not there. And usually that means, so these satellites, they are in the atmosphere, very small, like very diffuse atmosphere, but they are in the atmosphere. They're getting bumped around. So it means that either the satellite kind of drifted off course a little bit, which is interesting that no one caught that, or it means that they had to do some kind of maneuver. And that's also important to understand. Why did they have to do that maneuver? Because you don't want satellites to collide, and that suggests that maybe they were trying to avoid a collision.
So what we want to do on the long term, there is a lot of things we want to do. So let's talk about how we're going to improve this.
Yes.
So go ahead, tell us the plan.
All right. So currently, you'll notice that the scripts are all split up into 4, these different types of satellites. I want to make this a much cleaner, easier to use experience. I understand that right now it's kind of intimidating because it looks like there's a bunch of code there and there's like these weird boxes you got to fill out and the play button is very small to Franck. So I would love to be able to get these onto our website essentially in the background and have something similar to the Planetary Defense Ephemeris or the Comets Ephemeris, where you put in, or even the predictions page, you put in your location and the time that you want to observe, and it will go through this list and it will say, okay, here you have a Starlink, here you have a OneWeb, here you have a Kuiper, and give you those deep links. We are also working on a dedicated science campaign mode in our satellite science campaign mode in the app, because currently we're using the occultations mode. In that science campaign mode that's specifically designed for satellites, you won't have to do 2 deep links. Rather than something like at the end of a defense observation where it says, would you like to take dark frames? The science or the satellite's observation would say, would you like to take a longer exposure image? And it will, you just will be able to do it that way. You won't have to go back and forth between an ephemeris and develop and click on a bunch of different links. So that's something that I really would like to improve on the user end of making it much easier to do. And that's stuff that we are actively working on. For the back end, people in the satellites channel will probably know that it's very spotty on whether or not how quickly I get results. Sometimes it's a very intense process for me to go through these hundreds or thousands of images and quickly identify which ones have the satellite in them. This is where we're working with the astrophysics Marseille laboratory.
Laboratoire d'Astrophysique de Marseille.
I'm
very sorry for
So we're working, they're developing basically a machine learning algorithm that will automatically identify when a satellite is in the frame. When they have that done, that will greatly speed up my ability to find out which frames have satellites. And then ideally, I want a pipeline that can identify reference stars from these longer exposure frames. I want it to be able to compare the reference star magnitudes to the brightness of the satellite to get the magnitude that way. Currently, I have stuff where I kind of have to put everything in by hand. But ideally, this will be a fully automatic pipeline where you upload the data and then you wait, less than a day, and it will come back with this is the satellite, this is how bright it was, this is its spot in the sky, and we'll be able to submit reports about where these satellites are in the sky to our partner Spaceable, and to, I think it is Celestiac as well, if we find anything that is odd about where we see the satellite versus where it was expected to be.
So there is this kind of goal, which is to monitor the brightness and the position, but we will also do scientific campaigns specifically. So one of the most interesting, in my mind, scientific campaign we can do right now is to focus on the Starlink V2.
Generation 2.
Generation 2, because they claim that they made some modification, so the satellites will not be as bright as the Generation 1. So, but nobody yet has proven this, to my knowledge. So if you could observe as many as possible Generation 2 Starlink, we may be able to see whether or not this is true and how they mitigate, what the effect of this mitigation in brightness. Remember, satellites reflect the light of the sun, and the phase curve, which is the behavior of the brightness versus the angle, the illumination, is very complex because it can depend of the solar panel location. We can have specular effects. We can have some very weird things happening here.
Yeah, how reflective is any given surface? Does it paint it black, or is it painted with like some other extremely reflective color?
So we need to observe those satellites multiple times and multiple angle to truly understand the phase function, I would say, and see whether or not they are truly fainter than the Generation 1.
And I will say we are not the only group that is doing something like this or that is interested in this. Like I said, this is an astronomy-wide thing. There is a group called the Center for the Protection of the Dark and Quiet Sky, whose whole mission statement is to monitor the effect of satellites in the sky. They currently have the same campaign of observing Generation 2 satellites. Anything we find here, we'll be working with them. We can also show them the data as well, and we can start working together, collaborating with astronomers all over the world on this project with the idea of helping to mitigate what satellites are going to do to the night sky. But yeah, so currently, like Franck said, Generation 2 satellites are very interesting. There is a recent launch that went up, I think it was about a week and a half ago, that I've been monitoring. Once it gets to its full height, SpaceX has actually asked people to observe it because they want to get an understanding of how bright these specific satellites that they just sent up were. So once they're in their final orbit, or they're raised up as high as they're going to get, I'm going to put a call out as well on the satellites channel. So if you're not in the satellites channel, join it. But I'll put a call out there to observe these specific satellites, and I'll probably update one of the scripts so that it monitors those specifically. NORAD does track everything in orbit bigger than a nut and a bolt. but there are a lot of things up in the sky. So it is useful at the very least to double check that they're correct because
And NORAD also does not publish everything.
so that is part of the problem with space surveillance or space situational awareness is that these are a lot of private corporations, and while they all might genuinely want to make sure that their satellites aren't colliding with anything else, they also have a vested interest in kind of keeping their information secret because they don't want a competing organization to get an upper hand on them. So there is this kind of tension between what knowledge is out there and made available to the public and what knowledge probably should be out there, but also people are keeping close to the chest so that there's no chance that they get scooped in some way. So this is it's a touchy subject, but it's valuable information for us to observe these, even if NORAD is also tracking them, because NORAD's also not always right. Yeah, we need to get top secret clears. As soon as I figure out how to reliably find spy satellites, you can bet that's going to be a campaign. I'm going to ask everybody to observe those.
Any other questions? Are we good?
I think so.
All right. So we have 12 people who join us in this call.
We had 15.
Yeah, 15. Oh,
Yeah.
So that's we're gonna have 15 observations of satellites in the next week, right? All right.
Yeah.
Frankly, it seems kind of frightening at the beginning, and that's why we wanted to do this discussion with you. But it's not. It's really like generating this file is the most complicated part. You can do it beforehand. Relax at home. You prepare your file, you put everything on your phone, and you go outside or close to your telescope in your car, and you can observe easily. If you have any questions, you can text us on satellite, Slack. Ryan never sleeps, so he will answer to all your questions continuously. Right?
Famously always awake because Franck is constantly asking me to do things at like 3 or 4 in the morning. Never stops. No, he's fine. Yeah, so that's, if you have any questions, I like this campaign. We have kicked it off 2 or 3 times now, and it feels like every time, I think the first time we tried this was maybe a year or 2 ago, and we got a lot of interest, and then Planetary Defense kind of just kicked my butt for a while, and I wasn't able to stay on top of it. And it felt like people were interested, but then didn't want to get back into it. So we have dedicated time now. This is no longer just a passing interest for me. This is something where my job is to do satellites. And I would love for people to be as interested in this campaign as I am, which is part of why we're wanting to do this, because it is intimidating at first. But hopefully I have convinced you, we have convinced you of the necessity of this, and we've convinced you that it's not particularly hard to get into, and it can be quite fun.
And you can do it at the beginning of the night or at the end of the night. So if you wake up early, if you want to go to bed early, that's a perfect time. That's a perfect program. Okay?
Yeah. So if there are no other questions, which I don't see anything, then thank you, Ariel, again for standing out in the cold. Ariel,
Of course.
Lauren was going to do it, but she had some family stuff come up, so she was like, I can't anymore, I'm sorry. So Ariel, short notice, really absolutely hit it out of the park for me. Thank you very much.
Yeah, of course. It worked out. I have a clear night, so might as well.
Cool. All right, well, then I think we will all let everyone here go, unless there are, again, any questions. If you decide later that, I should have asked this, then feel free to send me a message or post on the Satellites channel, and we can answer it all there. All right. Thank you all very much. And this is recorded, so you can see it on Slack if you want to watch it back later. All right. Have a good night.
Have a good night.
Bye.